Mathematics Form 3. Ratio, rate and proportion to speed.
Hello, today we will learn about speed. Before we go on, let's look at these two situations. They may help us to understand about speed. In today's lesson, you will understand and perform computations involving speed.
Siva and Nathan took part in a 100 meters race. Siva clocked 11.8 seconds in the run, while Nathan completed it in 12.3 seconds. Who do you think ran faster in the race? When we ask who ran faster in the race, we are actually comparing their speed.
In the second situation, a car traveled 200 kilometers in 4 hours. This means that the car moved at a rate of 50 kilometers per hour, or it has a speed of 50 kilometers per hour.
Thus, speed is a rate that describes the distance traveled in a unit of time. You have learned that speed is a rate that describes the distance traveled in a unit of time. Speed equals to distance over time.
So, the two quantities involved in speed are distance and time. The unit used to describe distance is kilometer or meter and hour or second for time.
Example 1. The speed of a lorry on the road is 70 kilometers per hour. Determine the two quantities involved. Solution. The two quantities involved are distance, kilometers, and time, h.
We know that speed is a rate that describes how the distance traveled changes with respect to time.
Thus, speed can be calculated by dividing the distance traveled by the time taken. Speed equals to distance over time, or S equals to d over t. Example 2. A bicycle moved a distance of 180 meters in 50 seconds. Calculate the speed of the bicycle and give an interpretation of the values obtained. Solution. Speed equals to 180 meters over 50 seconds equals to 3.6 meters per second. This means the bicycle moved 3.6 meters in a second. By expressing the unknown d as the subject of the formula, we get d equals to st. Thus, the distance can be found if speed and time are given. Example 3. A car moves with a speed of 180 kilometers per hour. Calculate the distance traveled in 8 hours. Solution. S equals to d over t. Thus, d equals to st. Speed equals to 180 kilometers per hour. Time equals to 8 hours. Distance equals to speed times time equals to 180 times 8 equals to 1,440 kilometers. Thus, the distance traveled in 8 hours is 1,440 kilometers. Calculate the time given the speed and the distance. Now, by expressing the unknown t as the subject of the formula, we get t equals to d over s. Thus, time can be found if speed and distance are given. Example 4. A bus traveled at a speed of 80 kilometers per hour. What is the time taken to travel a distance of 412 kilometers? Solution. S equals to d over t. Thus, t equals to d over s. Given speed taken equals to 80 kilometers per hour and distance traveled equals to 412 kilometers. Thus, t equals to 412 over 80 equals to 5.15 hours. Thus, time taken is 5.15 hours. Convert speed from one unit of measurement to another.
You have learned that the unit for the rate can be converted to another unit that is equivalent. We can also convert unit for speed to another unit that is equivalent.
To convert speed from one unit of measurement to another, first, we write the speed as a division of the two quantities involved. Convert the unit of each quantity to the specified unit. Calculate the speed in the new unit of measurement. Example 5. Kasim drives his van from his house to his office, which is 15 kilometers in 10 minutes. Calculate the speed of the van in meter per second. Solution. 1 kilometer equals to 1000 meters. 15 kilometers equals to 1000 times 15 equals to 15,000 meters. 1 minute equals to 60 seconds. 10 minutes equals to 60 times 10 equals to 600 seconds. Given t equals to 15 kilometers equals to 15,000 meters. T equals to 10 minutes equals to 600 seconds. Thus, S equals to 15,000 over 600 equals to 25 meters per second. Thus, the speed of the van is 25 meters per second. Differentiate between uniform speed and non-uniform speed. Look at these two situations. Situation 1. The diagram shows a car traveling from town A to town E. The car takes the same time to travel from A to B, from B to C, from C to D, and from D to E, that is 2 hours. From A to B, speed equals to 50 over 2 equals to 25 kilometers per hour. So, the speed of the car that traveled from B to C, C to D, and D to E is the constant 25 kilometers per hour. Thus, we say that the car traveled from town A to town E in uniform speed. Situation 2. The diagram shows a car traveling from town P to town T. The car took 1 hour to move from P to Q, 3 hours from Q to R, and so on. The distance between all the towns are the same. In this situation, from P to Q, S equals to 50 divided by 1 equals to 50 kilometers per hour. From Q to R, S equals to 50 divided by 3 equals to 16.7 kilometers per hour. From R to S, S equals to 50 divided by 1 equals to 50 kilometers per hour. From S to T, S equals to 50 divided by 2 equals to 25 kilometers per hour. The speed taken by the car to travel from each town to another is not constant. Thus, we say that the car moved in non-uniform speed.
So, can you determine whether the speed taken by a man running down a hill is uniform or non-uniform? That's all for today. Until we meet again, goodbye.